So what if I told you there was this controversial technology that unlocked a massive new energy source right under our feet? I mean, it completely redrew the world's energy map in like a decade. Today, we're diving into this shale gas revolution, and it's a wild story of economic booms, big environmental battles, and a really complicated energy future. Let's get into it. Okay, so what is this revolution that's supposedly happening right under our feet? Well, for a long time, geologists knew there were these huge amounts of natural gas just trapped in deep layers of shale rock. The problem, we had no cost-effective way to get it out. It was locked away, seemingly forever. But then, something changed. A new technology emerged that was a total game changer. And that technology is hydraulic fracturing, or as pretty much everyone calls it, fracking. It's a really powerful process. Basically, it unlocks all that trapped gas by injecting a high-pressure mix, we're talking water, sand, and some chemicals, thousands of feet underground. This blast of liquid creates these tiny little cracks or fissures in the rock, and poof, it lets out the natural gas that's been stuck down there for millions of years. Now, I know it sounds super complex, but really, it all boils down to three main steps. First, they drill a well straight down, sometimes for miles, and then they make a turn and drill horizontally right through that layer of shale rock. Step 2, they perforate that horizontal pipe and pump in that high-pressure fluid we just talked about to crack the rock. And finally, step 3, they release the pressure and all that natural gas just flows right up to the surface. Simple as that. Well, kinda. And this process didn't just work. Oh no. It worked on a scale that, and I'm not exaggerating here, completely changed the world's energy map. So let's talk about the massive economic and energy boom that came next.
What's really wild here is just how fast all of this happened. Just look at the U.S. timeline. Around 2008, shale gas production just skyrockets. It goes vertical. In less than a decade, the United States went from worrying about importing energy to becoming a net exporter. That means it was selling more natural gas to other countries than it was buying. I mean, that is an absolutely stunning transformation.
So, what did this boom actually look like for people? Well, in places like Pennsylvania and North Dakota, it meant a huge surge in good-paying jobs. For the rest of us, it meant lower energy prices for our homes and for businesses, which helped fuel industrial growth. And, on a national level, it meant the U.S. didn't have to rely so much on foreign energy, which is a huge deal for energy security.
Okay, and here's one of the biggest arguments for shale gas, and it actually comes from a climate perspective, specifically when you compare it to coal. When you burn natural gas for electricity, it releases about half the carbon dioxide that burning coal does. In the US, this switch from coal to gas was actually a major reason the country's carbon emissions started to drop. But that is not the whole story. Not even close. You see, for every one of those economic upsides, there's a really serious, really complex conversation we need to have about the environmental and social costs. So now, let's flip the coin over and look at the other side. Let's just start with water. The scale here is, well, it's staggering. A single fracking well can use millions of liters of fresh water. We're talking enough to fill several Olympic-sized swimming pools just for one well. Now, if you're in a place that's already dealing with water shortages, you can see how this level of consumption becomes a major environmental problem.
And the concerns definitely don't stop there. There's the fiercely debated risk of the chemicals in that fracking fluid getting into groundwater supplies. Then you've got this weird phenomenon of induced seismic activity. Yep, small, human-caused earthquakes that have been linked to how they dispose of the wastewater deep underground. Add to that all the disruption to ecosystems, the landscape getting carved up, plus local air and noise pollution, and you've got a pretty significant list of downsides.
And all this brings us to what might be the most complicated part of this entire puzzle, the climate picture. Right, we just said that gas burns cleaner than coal, which sounds like a clear win. But the reality is so much more nuanced, because this story is about more than just carbon dioxide. This quote from our source material really gets to the heart of the problem. Natural gas, it's mostly methane. And if that methane leaks into the atmosphere before it gets burned, say from the well itself or from pipelines, you've got a serious climate issue on your hands. Why? Because methane is an incredibly powerful greenhouse gas. It's way better at trapping heat than CO2 is.
Yeah, this slide really lays out the trade-off perfectly. On the one hand, you have the CO2 advantage. When you burn it, natural gas is a clear winner over coal, no doubt. But on the other hand, you have the methane problem. Any methane that leaks out is over 80 times more potent than CO2 at trapping heat, at least in the short term. And what that means is that even really small leaks can have this huge outsized impact on the climate.
So here's the billion-dollar question. Does the climate benefit we get from lower CO2 emissions get canceled out or maybe even reversed by the damage from all that leaking methane? Honestly, the answer to that question is one of the most heated debates in energy science right now. And it's made even harder because it's so difficult to accurately measure just how much methane is actually leaking out.
Okay, so with this really complex picture of pros and cons, it's probably no surprise that the world hasn't exactly embraced this technology in the same way everywhere. This isn't just an American story, it's a global one, and different countries have had very different reactions.
And you can see that split perfectly. If you just compare the United States and the United Kingdom, in the US, they largely went all in, right? They prioritized the economic boom and the idea of energy security. But over in the UK, it was a totally different story. Proposals for fracking there faced intense public opposition. You had grassroots campaigns all focused on the environmental and safety risks, and that led to a much more cautious and ultimately stalled approach.
And that contrast really brings us to the fundamental trade-off, the core dilemma that fracking presents to every single society. It forces us to ask a really tough question. How do you balance these very real, very immediate economic and energy needs with the potential for long-term and maybe even irreversible environmental damage?
Which leaves us with the ultimate question, the big one. Supporters of fracking call shale gas a necessary bridge fuel. You know, a cleaner burning fossil fuel that can power our transition away from dirty coal while we build out renewables. But opponents, they argue it's just a costly dead end, a carbon-emitting distraction that locks us into fossil fuel infrastructure for decades to come. So is it a bridge to a renewable future, or is it a costly dead end? That is the debate right at the very heart of this revolution under our feet.